3.3 Properties of Functions. We're going to talk about symmetry again today. So if you weren't too confident on symmetry back in chapter 2, go back to chapter 2.2 and revisit symmetry again, okay? Alright, so determine even and odd functions. So later on in math, we'll break down more and more what even and odd functions mean and why they're important to know and what they tell us about a function. So basically what these yellow boxes are saying is if it's an even function, it's y-axis symmetry. If it's an odd function, it's origin symmetry. It's one or the other, or none. So remember in symmetry you had to test all three. You just had to do all three. Here, once you have the answer, you're done. It's either even or it's odd or it's neither. Just like numbers. A number is even, a number is odd, or it's nothing, which is 0. Alright, before we get to that, let's talk about something with intervals. So intervals, that implies x values. So we're going to go where x is -2, right here, and where x is 1, right here. Now what we're going to do is we're going to look at what the graph is doing. So at that point, in between those lines, the graph is going down. So since the graph is going down, are we decreasing? Yes, we are. That's the answer. Yes, we are decreasing right there. Remember, intervals, that implies x values. Let's determine whether each graph is the graph of an even function, an odd function, or neither. And we're going to do that using symmetry. So as a reminder, remember, even is y-axis, odd is origin. So if I fold it, I have to imagine folding each graph. So if I'm looking at this first graph right here, that first graph, which way would I fold it to make it go on top of each other? I would fold it down. You would fold it down, which is over the x-axis. Since it's over the x-axis, we would say this is x-axis symmetry. And x-axis symmetry has nothing to do with even or odd, so this would be neither. Also, we're talking about functions. We're talking about even and odd functions. Function. This isn't even a function. If you did the vertical line test, it's not even a function, so how can it be even or odd when it's not a function? Alright, I'm going to go down here to that one in the middle. So which way would we fold it? I would say we fold it over this way to make it go on top of each other. And that's folding over the y-axis. So we fold it over the y-axis. So we would say that's y-axis symmetry. Since it is y-axis symmetry, we know that this is an even function. So this is an even function, just because it's symmetric with respect to the y-axis. Alright, last one. Whenever it looks like an S like this, you're usually going to fold it over the origin. So we fold it over the origin. So we fold over the origin. So because of that, we would say that this is origin symmetry. And because of that, we know that this is odd. How do I remember the two? Well, it's either even and odd, and it's either origin or y-axis. So origin odd, O goes with O. By default, the other one's even and it's y. But I can remember origin because origin odd, they both start with O. Let's find even and odd functions with equations. So example 3, we're going to determine whether each of them is even, odd, or neither, and what type of symmetry it has, whether it be y-axis or origin. So part A, we have x squared minus 5. Okay, what I'm about to teach you is just a where do I start. what's the best first step you could take? It's like when you're baking something, your first step is to turn on that oven, right? So this is kind of like that equivalent. Like, what's the first step should I take that will set me up for success? It doesn't work all the time. So if we look at the exponent, it's a 2. 2 stands for even. That's an even number. So I'm going to test even. I'm going to test it with y-axis because that's what it is. Even is y-axis. And remember, y-axis, we switch the x. So we have y equals negative x squared minus 5. We simplify to get y equals x squared minus 5. And we do the same thing we did in chapter 2. That's why I said if you're not confident with symmetry, go back in chapter 2. So what we do is we compare it, and it is the same. It's the same as the original equation. So we say that this is even, and it is y-axis symmetry. That worked. We're done. It worked. We found the answer. Move on. It's not like in chapter 2 where we had to keep going. This, done. So the trick is start with that exponent. It usually works. So start with even. It worked. All right, next going on to B, we have an odd exponent. So I'm going to try odd first. So odd, remember that's origin. So origin, we switch both. So we're going to switch both in that equation. We'll have negative y equals negative x cubed minus 1. So negative x cubed, remember that's negative x times negative x times negative x. So we have negative y equals negative, 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 stays negative. X times x times x, x cubed minus 1. We're not allowed to have negative y, so we multiply it. And we have y equals x cubed plus 1. You see how that didn't work? It did not work to the original equation. It didn't work. So see, it's a trick on where to start. It's just how, because that's a lot of times in math, it's like, where do I even begin? That's why I tell you, look at the exponent, because it's going to give you a starting point. It did not work for odd. So since that is the case, we have to try even. We have to. So even, that's the y-axis. We switch x. So we have y equals negative x cubed, and we know what that is. It's y equals negative x cubed minus 1. That's not the same thing as the original. So this is neither even or odd. It is just a random graph in there. Alrighty, part C. I want you to pause it and try it on your own. Remember, look, I'll give you one hint. That's the hint. I circled the 3. Alright, I hope you tried it. If you didn't, pause it. Try it. Okay, alright, let's do this together now. So, since that is an odd exponent, I'm going to try odd first. And remember, odd, wrong color. Odd first. And since it's odd, we know that's origin symmetry. And origin, we switch both. So we have negative y equals 5 times negative x cubed, all minus negative x. You see why every time I have x, I wrap parentheses? It's so I don't mess up right here. That's why every time I have an x, I do parentheses, then I go back. It's one of the many reasons why I do that. So let's simplify. We have negative y equals negative 5x cubed plus x. We're going to multiply by negative 1. So we have y equals 5x cubed minus x. That is the same thing, so this is odd. And since it's odd, it's origin symmetry. So what I want you to do is go back to your work, if you did try this, and see if you got it right. Awesome. If you didn't, that's fine. You're just learning this and applying it to something new. So figure out where you messed up. I probably know. It's probably right here. It's probably that minus part. So every time you have a variable, put parentheses, then go back. Alrighty, part D. So part D, we have y equals, it's not y, it's f of x. We'll switch it to y. We have f of x equals absolute value of x. which is just y equals, what is the absolute value of x always? Isn't it always going to be positive x? So this is actually what we're going to be working with. We're going to be working with y equals x. So there is no exponent here, but there kind of is. There's a 1 there. There's a 1. Since there's a 1 there, let's try odd first. So odd is origin. All right, we're going to test origin. So for origin, we have negative y equals absolute value of negative x. And what's the absolute value of negative x? It's always x. So we have negative y equals positive x multiplied by negative 1. And when we do, we have y equals negative x. That's not the same thing. This is what we're going to compare it to, and it's not the same thing. So let's try even. So even, remember that's y-axis. So for y-axis, we switch x. So we have y equals the absolute value of negative x. We know what the absolute value of negative x is, positive. And if we compare it, it is the same thing. So this is even or y-axis symmetry. All right, use a graph to determine where a function is increasing, decreasing, constant. Then we're going to list intercepts, if any, find the domain and range. So the first thing we're going to do is find the domain. So the domain, remember, those are x values. Since this has a start and a stop, it's smallest x to biggest x. So -6 to +6. Brackets because they're closed circles. The range, remember, those are our y values. So same principle, smallest y to biggest y. So smallest y is -2, biggest y is 4. So -2, +4. Again, bracket, closed circle. Let's list our intercepts. Remember, intercepts are anything that fall on the axis. So we have x-intercepts at -6, 0. My bad, it's telling us to list. Remember, list just the number. So we have -6, -2, and our y-intercept is 4. I'll highlight those so you know where I found them. Those. Now let's do increasing, decreasing, constant. Those 3 words imply intervals. And what do intervals imply? X values. We only care about x. So x values. So we're looking for x values. So increasing, right, that means going up. Decreasing, right, that means going down. And constant, what does that mean to you? Flat. So let's see, do we have a part on this graph that is flat? We do. It's from here to here, that's flat. So from what x to what x? 0 to 3. Intervals are always parentheses. When you're talking about increasing, decreasing, constant, intervals are always parentheses. All right, let's talk about decreasing. We'd go down twice, but separate occasions. So from what x to what x? -6 to -4. Since there's a break, we union. And then another x from 3 to 6. All right, we increase only one time because we don't stop. We did not stop here. So it's from -4 to 0. Why aren't we counting the 2 right here, the -2? Because remember, intervals, it's -4 to 0. So it has all those numbers in it. Use a graph to locate local maxima and local minima. So local maxima and local minima, that's the points on top of a hill and bottom of a hill. I'll explain that more as we go along. So part A, it wants us to find the local maximum. So the local maximum, I like to think of that as all points on top of a hill. So on our graph, we look for a hill and we look for points on top. And we do, we have that right there, 1, 2. So we have the point 1, 2. But since we're talking about for what value or values of x, and we're talking about function, you see how that little f, that means function, we have to answer in f of 1 equals 2. So local minimum, is just the opposite. So the opposite of a hill is a valley. So it's all points at the bottom of a hill. So all the points at the bottom of a hill, so basically like where it swoops down. So we have two of those. We have 2 points of -1, 1 and 3, 0. So our answer is f of -1 equals 1 and f of 3 equals 0. Alright, let's find where this is increasing, decreasing. It's not constant, so it's not going to even ask for it. So increasing is when the graph goes up, and we read left to right. So it goes up here, and it goes up here. So it goes up from -1 to 1. Since there's a break, remember that means union. And then 3 arrow means forever, so 3 to infinity. We read left to right. So if we're starting on the graph here, we have to go down to get to the point. So we're decreasing from -infinity to -1, and then again from 1 to 3. So for local max, local minimum, you can have a bunch of answers. For absolute max and absolute minimum, you really only have one answer. It's only one answer because absolute means the biggest, the most, the least. So let's find our absolute maximum. So it's the highest point. It's 3, 6. So f of 3 equals 6. Now the minimum, pretty much same idea except the smallest, lowest point, 0, 1. So f of 0 equals 1. Alright, so for b, we do our maximum. So our absolute max, that's the highest point, it's 5, 3. So f of 5 equals 3. And our minimum, our absolute minimum, that's still the lowest point, but you see how it's an open circle? So since it's an open circle, we don't have a minimum. That means this graph will never have a minimum. It doesn't have a smallest point. Alright, C. So we have our absolute maximum, highest point is 5, 4. So f of 5 equals 4. Our absolute minimum, we have 2 of them. Anytime you have multiple on the same level, you're going to write this in interval notation. So from 1 to 2. Remember, those are x's. Those are x values. So that means from 1 to 2 will give you your minimum. Alrighty, part D. We don't have a highest point. We have an arrow. That means we don't have a maximum. And doesn't it just keep going forever? So that means there's no maximum. Our minimum, it's 0, 0. I want you to pause and try doing this one. It is a trick question, so be careful. Alright, I hope you tried it. So let's go to the highest point. I don't care if there's other points. Go to the highest point. It's open circle 1, 4, so there's none. Now I go to the lowest point. It's an arrow going down, so there is no minimum. Alright, average rate of change. This is going to be given. That's given. That formula is given. So average rate of change is delta y over delta x, meaning f of b minus f of a over b minus a, and a cannot equal b. So let's find the average rate of change of f of x equals 3x squared from 1 to 3. That is our a, that is our b. So I'm just going to plug it into our formula. We have f of b minus f of a over b minus a. So f of b, so 3 minus f of a, which is 1, and 3 minus 1. I'm going to take this part out, f of 3. That tells us to plug 3 into the equation they gave us. So we have 3 times 3 squared, that's 29. So f of 3 equals 29. Now we do f of 1, so same idea. We're going to plug 1 in as x. So we have 3 times 1 squared, which is 3. So f of 1 equals 3. Now we simplify the bottom. 3 minus 1 is 2. So we have 29. My bad. 27. Why did I say 29? 27. I don't know why I said 29. It's 27. 3 times 3 is 9. 9 times 3 is 27. Okay. 27 minus 3 is 24. And 24 divided by 2 is 12.